Hello friends, in this video I'd like to solve the following problem from the Korean Mathematical Olympiad, final round year 1994, problem number 2. Let alpha, beta and gamma be the angles of a triangle. We wish to prove that cosecant squared of alpha over 2 plus cosecant squared of beta over 2 plus cosecant squared of gamma over 2 is always greater than or equal 12, and then we wish to find the conditions for equality. So for what angles is this equality attained? This problem is rather easy. My hints are the following. Use mathematical analysis, calculus, to show that our function, which appears here, here, and here, is strictly convex on the interval from 0 to pi, and then use Jensen's inequality. And also remember that if you are not familiar with this notation, cosecant squared, cosecant is just 1 over sine. It's just 1 over sine. So give this problem a try and I will see you in a minute. Okay, so as I suggested, let's consider f of t equals cosecant squared of t over 2, which is the same as 1 over sine squared t over 2 for t. We only need from t from 0 to pi, because angles of a triangle are between 0 and pi. And now we need to differentiate it. I'll leave this part to you because it's boring. It turns out that our first derivative is minus cosine of t over 2 over sine cubed of t over 2. And crucially, the second derivative is crucial. Our second derivative is 2 times cosine squared of t over 2 plus 1 over 2 times sine the fourth power of t over 2. What do we see? We clearly see that our function is, our second derivative is strictly greater than 0 for t between 0 and pi. In fact, it's also true between 0 and 2 pi, because our function is defined on the whole interval from 0 to 2 pi, but let's restrict ourselves only to this interval, which means, and that is crucial observation, powerful fact from mathematical analysis, that means that f is strictly convex on the interval 0 pi. Okay, very well. And now let's notice that what we wish to prove. We wish to prove that cosecant squared of alpha over 2 plus cosecant squared of beta over 2 plus cosecant squared of gamma over 2, we wish to show that it's greater than or equal 12. And notice that that can be written in equivalent way: f of alpha plus f of beta plus f of gamma over 3 is greater than or equal 4. Now, by Jensen's inequality, since our function is convex, we know that f of alpha plus f of beta plus f of gamma over 3 is greater than or equal f of alpha plus beta plus gamma over 3. And moreover, equality happens, equality is attained if and only if alpha equals beta equals gamma. Okay, and now let's find what is f of alpha plus beta plus gamma over 3. Well, f of alpha plus beta plus gamma over 3. Alpha plus beta plus gamma is pi, so it's pi over 3, f of pi over 3. So it's cosecant squared of pi over 3. And what is cosecant? Cosecant, again, is 1 over sine. Sine of pi over 3 is sine of pi over 3. It's what exactly? Sorry, my bad. It's pi over 3, but also divided by 2. So it's pi over 4. Sine of pi over 6, sorry. Sine of pi over 6 is 1/2. So it's 1 over 1/2 squared, it's 4. So it's 4. And so that concludes our proof, to be honest. Which means that, in fact, f of alpha plus f of beta plus f of gamma over 3 is in fact greater than or equal 4. Moreover, when is equality attained? Well, only for equilateral triangle. Equality is attained only for equilateral triangles. And that closes our proof. Pretty standard application of Jensen's inequality. And I suggest that you remember this inequality because it will be used as a lemma in other trigonometric inequalities in a triangle. So keep this result in the back of your mind. Okay, thank you for watching and I will see you next time. Goodbye.